Hello. All right, I am going to get started. If you guys would please grab a board and marker. Depending on what happens with the weather this week, this could be one of the last videos. So we are all in next week. Okay, guys, what we're going to do is we're going to review from yesterday to start class today. And in order to do that, I'd like you to try these 4 problems, which are going to be the distance on the coordinate plane that we have been already working with. So please do 1, 2, 3, and 4 on your boards. You may need to pause the video if I'm going a little bit too fast so you have plenty of time, and we will check these then. Okay, just as a review, you're looking at what's the same, the x or the y. So in number 1, the y is the same. So how far is -1 from 5? It would be 6 units. I'm just going to do U for units. Number 2, the x is the same. -9 and -1 are 8 units apart. We're just talking distance here. Number 3, the x is the same. -6 and 0 are 6 units apart. Sorry how sloppy my U's are. And finally, number 4, the x is the same again, and -2 and 12 are 14 units apart. 6, 8, 6, 14, okay, for those. All right, here's a tough one to start class today. This is good for those of you that think that some of the graphing stuff's been too easy. I would like you to try to find the perimeter, which means the distance around this rectangle without using grid paper. Okay, the distance around this without using grid paper. Give you guys a little time to see if you have any clue how to do this. This is a very tough question. Okay, I'm not sure if anybody thought of how to even do this, but we're basically finding the distance between the points. So like how far apart are -6, -2, and -6, 4? They are 6 units apart. How far apart would -6, 4 and 1, 4 be? They are 7 units apart. How far apart would 1, 4 and 1, -2 be? They are 6 units apart. And some of you are probably thinking that's your answer. But you still have to connect this point all the way back to the beginning one. So how far apart would 6, -2, 1, -2 be? And those would be 7 units apart. Now I have a shortcut for these though. Think about what a rectangle is. It's a parallelogram. So if one side of the rectangle is 6 units, the other side has to be 6 units. And if one side is 7 units, the other side has to be 7 units. Sorry about the shade there. So when we add all of these up, or any way you add them, you're going to get a total of 26 units. At the end of the video, I think I'm going to come back and maybe give you guys one more of these to try. It's a good challenge. It kind of connects the whole unit together with graphing, with distance, with shapes. So it's a really, really, really good problem. I want you guys to be able to do these without grid paper, and you can do it. Okay? All right, today's lesson. I'll tell you what, let's do it. I set it up this way. Let's do it right now. So I'm going to give you guys a minute here, and I'm going to have you try just this one right here, the top one. We'll maybe try the other one a day down the road at school. Find the perimeter of this figure without grid paper. Go ahead and give it a shot. Okay, assuming some of you are not done, pause the video for me. And here we go, let's check it. Okay, so the first set of points here. 2, 9, and 2, 15. The x is the same, so the 9 and the 15 would be 6 units apart. Okay, so I'm going to change the colors up here. If I go to the next one, now the y is the same, and the 2 and the 0 are 2 units apart. So think about this. If one side of the rectangle is 6 units, come on, there we go. The other side of the rectangle is 6 units. And if one side of the rectangle is 2 units, the other side of the rectangle is 2 units, which means that the total perimeter would be 16 units of that rectangle. Okay, not something you'll be quizzed on, but it is something that's pretty cool if you can do. Okay, what is a reflection? A reflection is basically a mirror image. When you look in the mirror and see something, as I have a Cowboys on my shirt, okay? There we go. There's the Cowboys, all right? The mirror image will not say Cowboys, it'll be Cowboys backwards. So like if you had a line that was a mirror and you had the letter E, what you would see is like a backwards E. It's a mirror image. It's a reflection. It's like flipping a pancake, all right? Now, we can do this with points, okay? So we're going to do a few of these together. Let's start with, let's assume here that we have quadrant 1, which we know is positive, positive, quadrant 2, negative, positive, quadrant 3, negative, negative, and quadrant 4, positive, negative. So I'm going to put a point here, and the coordinates for this point, which I know you all know by now, are 3, 2. If I were to reflect this across the y-axis, okay, all that is, and I'm going to write this out, all that means is my mirror is the y-axis. So I'm going to kind of darken this in so I know where my mirror is. Whatever I reflect it across is what I'm flipping it over. So if I reflect this across the y-axis, my point would be negative 3, 2. Notice, the y did not change. What changed is the x. That would be the mirror image of that point across the y-axis. What if I would have reflected this across the x-axis? Then my coordinates would have been positive 3, negative 2. Notice, if I reflect it across the x-axis, what changes? The y. Okay, we're going to do some of these, and I want you to do these with me on your whiteboard. So we'll do 2 or 3 for practice. I'm going to put a point. The first thing I want you to do is to give me the coordinates of the point. So we're in quadrant 3, which means negative x, negative y. What would be the ordered pair? If you said negative 3, negative 1, you win $1 million that I don't have, okay? Negative 3, negative 1. So we're going to reflect this across the x-axis. What would my new coordinates be? All right, if we reflect this across the x-axis, we're flipping the pancake over the x-axis, and the new coordinates would be negative 3, positive 1. Notice when we reflect it across the x-axis, what changes? Yes, the y value changes, not the x. The x actually stays the same, okay? Let's do another one. So let's go with this point right here. Give me the coordinates for this point, please. So it would be 1, 2, 3x. That's a positive 3 because I moved to the right. And 1, 2, 3, 4. And that's going down on the vertical y-axis, so it's 3, negative 4. If I reflect this across the y-axis, I'm flipping it over the y. What would be my new coordinates? And you're right. Now the x value would change since we're flipping it on the y, and it would be negative 3, negative 4 in quadrant 3. Okay? All right. These are the type problems that you're going to do today. So you guys should have this worksheet. This is on the back. It's there to help you if you need it. Okay, and it says coordinate plane distance and reflections. What I would like you to do, the first 4 are just more distance practice. okay? And the next 4, you guys, I'm okay with you sketching these out and using your grid if you need to, all right? Um, I'm not going to give you a key for this today because I really want you guys to do this on your own, and I want to make sure everybody's practicing these. Even if you miss a few of them, it's totally fine. Just do your best, okay? And the next time I see you guys, either in the video tomorrow or next week, depending on what happened with the weather this week, we will go over this. So like I said, at the beginning of the video tomorrow, or if you're seeing this on a Friday and we're into next week, the next time I see you guys, we will go over these and keep reviewing them. So this is your assignment. You should all have a paper copy. If you don't, there's another one in the classroom. There are only 8 questions here. I did include a grid on the back so that you have a resource if you actually want to graph them to see what's going on. Hopefully this makes sense. You guys are awesome. Have a great day.